Hello everyone and welcome back to another edition of Building Design Fundamentals with your host Jonathan Asher. Today we're going to talk about the position component command. The position component command has been released not long ago, and in the 26x version you see here, it's compatible with a number of different components that we have delivered on the Buildings and Infrastructure wiki page on the public community. You see a number of the different parametric components that have been modeled and delivered. Televisions, chairs, desks. We have specific furniture for hospitals, including hospital equipment. There is equipment for HVAC components, plumbing components, electrical components, bathroom fixtures, lighting fixtures, security fixtures, all kinds of object types that have been modeled compatible with the position component command. So I've been modeling this residential unit recently. You'll see more on this model in the future. And there's one component that has not been delivered on our wiki that I need to represent or to block out some space in my building, and that is a kitchen. You see I've got space for a kitchen right there. But if you navigate the wiki, there are tables, there are chairs, there are sinks, there are toilets, but there is no kitchen. So I thought I'd take this opportunity to do just that, to model a new kitchen component that's compatible with the position component command that I can place in my model in these two locations. So we're going to do that today. Let's start by creating a new part, a furnishing element. I'll name this kitchen UDF, and inside that furnishing element, I'm going to create a new part. Inside that part, we need a base axis system. That will be the input to our UDF, and that will be the only input to the UDF. You cannot pass additional inputs into this object type using the place component command. I'm going to name the first geometrical set kitchen UDF because we're going to be modeling a UDF today. And I'm going to make a couple of parameters. The first is going to be a string parameter, and this is going to control the positioning of the kitchen relative to the base axis system. So when I create that parameter, it's going to be a type string, and I'm going to give it 3 different inputs, so it's a multi-value parameter, left, center, right. I'm also going to make a length parameter and an integer parameter. I'm going to copy the parameter set and paste that onto my kitchen UDF geometrical set. Rename it control parameters, and then I'm going to rename the other parameters so that they're easy to track and easy to control, and that they have a logical name in the UDF when we create that later. I have position, cabinet width, and cabinet number. The cabinet width, by default, will make that 60 centimeters. Cabinet number, the first time around, will make 6 cabinets. And now I'm going to make a new geometrical set. Rename the first one position. Rename the second one construction. And I'll have a third one that I call outputs. In the position, this is going to be a reference axis system based on the base axis system. The position component command is going to create a new axis system on the fly, and that's going to serve as the new reference for this new base axis system that we just created when we instantiate this UDF into the model. So with our new base axis system created, we're going to create a couple of points, and these points are going to be the positioning location of the kitchen and the sketch that's going to define the cabinetry and the refrigerator. So the first point is going to be defined by a formula. The formula is going to be our cabinet width times our number of cabinets. You see it's pretty simple to create this formula. You just click on the parameter in the tree and it will insert that into the formula dialog box. Type in the multiply sign and then click on the other parameter. This point is going to be our right point. So we're going to give it a name by right-click properties, call it right point. Next, copy that point, paste that point, open up the dialog box to modify the formula. This is going to be our center point or our midpoint. So we're going to modify the formula by dividing the equation by 2. And finally, we're going to make a left point. That left point is going to be 0. So for that, we don't need a formula. Let's delete the formula and just add 0. So we have our right point, our midpoint, our left point. We're going to take one more point here, and this is going to be our position point. This point is going to be isolated, and we're going to define this point by a rule or a reaction. But first, we need to move the relations. So the formulas that we just created need to go from the relations set that are at the top of the tree into our geometrical set that defines our UDF. And we do that by copying the relations at the top of the tree, pasting them onto our geometrical set. You'll see that the formulas are deactivated. So let's delete the original formulas and activate the existing formulas. Now I accidentally deactivated the position point instead of isolating it. I need to isolate it now. And so long as I have the building design engineer role that includes the engineering rules capture application, when I select the relations in the tree, it gives me the option to create either a rule, an action, reaction, all of that great knowledgeware goodness. For the time being, I'm going to make a reaction, and we're going to listen for the position parameter to see if that changes. If it does, the following code is going to be run. So let's write our EKL code in the dialog. If the position parameter equals left, then I want my position point to equal my left point. Else if the position parameter equals center, I want my position point to equal my midpoint. And finally, there's only one final option, so I don't need to write else if. I can just be a final else statement. If any other condition is met in the dialog box, then I want my position point to equal my right point. Check your syntax. I missed an equals. All is good now. Type OK, OK, and you'll see that that position point now is based on the reaction. And if that parameter changes, it's going to trigger that code, that little script to activate. And you'll see when I check this, the position point is being updated. It does equal either the right point, the midpoint, or the left point, depending on that parameter. Now, I'm going to make an axis system relative to the new base axes, but positioned at the position point. Now, when I change the position parameter, left, center, right, the axis system is going to be positioned on the position point, which equals either the right point, the midpoint, or the left point, depending on the parameter value. I noticed also now that my right point and midpoint are actually going in the wrong direction. So I just need to add a little minus sign to the formula so that when I change the parameter, the right position point is actually moving to the left because the kitchen is going to be on the right of that point that is on the left. Easy, right? Let's save. Now we're going to make a bunch more parameters to define the logic of this. We're going to make a Boolean, and that Boolean is going to decide whether or not there's a refrigerator or not. We're going to make another parameter that is of type width by copying cabinet width and pasting it on the control parameters set. That's going to be called refrigerator width, and we'll change that to 800 millimeters. We're going to copy the length parameter from up above, paste that down below. This one's going to be called kitchen length. That's going to be a resulting parameter of the overall width of the kitchen. So we're going to edit the formula of this value, and we're going to make a conditional statement in this formula. This is a very powerful yet somewhat unknown functionality within the formula dialog box, and that is you can create these conditionals. You select the parameter. If it equals true, question mark, then return this value. Else is the semicolon, return this value. So in this way, the kitchen length parameter is going to be one value if the refrigerator is true, or another value if the refrigerator Boolean parameter is set to false. Again, this is incredibly powerful, and we'll use this quite a bit as we move along with the modeling. Let's test that behavior, and you'll see now when I change the parameter value to kitchen to false, the value is different than if I have it set to true because the math equation behind that is different. Now, rather than doing the math and the formula for the right point and the midpoint, we're just going to use the kitchen length parameter in our other formulas because it contains that intelligent conditional statement within it. So by changing the refrigerator to false, the kitchen value parameter is going to change. That means the formulas that drive the location of our right point and midpoint are also going to change, creating very sophisticated parametric relationships now between the parameter sets and the resulting geometry using conditional statements and formulas. And this is going to form the basis for how we model all of the following geometry as well. These formulas are going to show up again. The conditional statements are going to show up again. And we're going to build a pretty robust model on top of that logic. Let's rename that axis system that we created earlier, Kitchen Sketch. And now let's make a sketch. This sketch is going to define the cabinet geometry. So let's make a rectangle. Let's set the length of one of the rectangle edges to the kitchen length parameter. We don't have a kitchen depth parameter yet, so let's actually cancel this formula. We're going to have to exit the sketch. But first, before we exit, let's make an output profile. Now let's exit the sketch. Let's copy the cabinet width parameter. Let's paste that into our control parameter set. Let's rename that cabinet depth. We'll leave it at 600. And now we can go back into our sketch and set the depth value of this rectangle to our depth parameter. Excellent. That's pretty narrow. We can exit the sketch. We need another length parameter here. This is going to be cabinet height, and this is going to define the value of the base of our cabinets extruded up as a volume. Should probably call that base cabinet height because we are going to have another parameter that defines our upper cabinet height. We're going to have cabinets on the bottom, a work countertop, and then cabinets on the top. We need another string parameter, and that's going to define where we have our refrigerator. Is it on the right or the left? So let's edit the string values for this multi-value parameter to just left or right. That's where our refrigerator is going to go. And let's add a couple of other dimensions, the refrigerator depth and the refrigerator height. Refrigerator height is going to be 2 meters, and the refrigerator depth we'll leave at 800. Now we're going to go back into our sketch after we rename this cabinet sketch. We're going to go back into that sketch, and we're going to add a rectangle for the refrigerator. So let's select the rectangle command. Let's make sure that these edges are associated with the refrigerator depth parameter via a formula. Do the same thing for the refrigerator width. Connect that to the width parameter via a formula. All of these formulas are going to be created inside the relations set outside of my geometrical set. I'm going to have to move them back later. And we need to make a modification to the overall cabinet width. It can't be the length of the kitchen because that includes the width of the refrigerator. So we need to subtract that. And then we're going to move these around in a little bit. Let's make sure that the refrigerator is actually well positioned relative to the cabinetry. So we need to do that by making sure that they're properly constrained. Let's make a coincidence constraint and make sure all of the other geometry is properly constrained as well. Once we're sure that the geometry is good to go, we can exit the sketch. And we're going to have to move some of this around depending on where the refrigerator is positioned, if it's on the left or if it's on the right. So based on the sketch, we already have the refrigerator positioned on the left and we have the cabinetry positioned on the left. We need to make a translate curve for the kitchen condition should it be found on the right, and for the cabinets, should the cabinets need to go on the right. So let's translate those two curves, and we're going to translate them with a formula. The formula is going to be equal to the values that we've already put in the parameter set. And now let's name all the geometry so that it's clear. We've got our cabinets left, refrigerator left, our cabinet right, refrigerator right, and that's clearly set in our tree and in our model. Now we're going to copy and paste those two translated curves, and we're going to paste them as result. This way, these are dead isolated geometry. We're going to call this the fridge result and the cabinet result, and we're going to define these curves with a reaction. So again, select relations, create a reaction. We're going to listen for the refrigerator true or false value. or the refrigerator position, left or right value, and we're going to write the following code. If the refrigerator is on the left, then the fridge result curve equals the fridge left curve, the output curve from the sketch. And the cabinet's result curve is going to be the cabinet's right. Else if the fridge should go on the right, let's copy and paste that code and say the cabinet's result will then be the cabinet's left, and the fridge results will be the fridge right. Check your syntax. I messed up on my syntax here. It's got to be the curve equals the curve, and the cabinet's result equals the right curve. So always double check your syntax. It's easy to make mistakes. We all do it. Click OK, OK. And now when those parameters change, the resulting geometry is going to be set based on the parameter condition that's being met and being defined in the reaction. Excellent. So you see we're layering intelligence into this model. We're making decisions on what geometry should be output and what geometry should be used based on the different configurations that are being defined with our parameters. Now let's make the cabinet extrude. This is going to represent the base cabinets. We'll do a fridge extrude. This is going to be also linked to the parameter value of the fridge height. Let's give it a name. Cabinet base, that's the volume. Refrigerator volume, those are going in the outputs geometrical set. And let's make another volume, copy pasting the cabinet base. This is going to be the upper cabinets. So we have to be a little more clever with the formula values here. The top is going to be the base cabinet height plus a gap plus the upper cabinet height. We're going to hard code that gap right now at 600 millimeters. We will make a parameter for it later. The bottom then is going to be that 600 millimeter gap plus the base cabinet height. Make sure it's minus minus, otherwise we're going in the wrong direction here. Minus minus, okay. Now look at that. We've got a pretty good looking kitchen space reservation here, and it's parametric. If we want the fridge on the left or the right, we just change our parameter, and now these curves are moving around. Our volumes are going to move around. Everything is so far so good. However, I'm running into an issue here. I remember when I said we're going to do all this with reactions, listening to parameters. Well, that's probably not the best way to do it. We're going to recreate these reactions as rules. The difference between a reaction and a rule is a reaction waits for a parameter to trigger the update. The rule just listens for any change in the model to trigger an update. So now we're not going to be constrained by whether a parameter changes or not. Regardless if any parameter changes, these rules now are going to be triggered and the geometry will automatically update. So it's the same code. We'll copy the code from the other reaction. We'll paste the code into our new rule. And you see now the icon of the feature in the tree that's being defined by the rule has changed, and it's got a little f of x icon on top of it. Excellent, that's what we want. And now we see when we change any parameter, we're getting an update to our model. We don't have the refrigerator visibility set right now dynamically, which is why you can't really test that so well right now. We're going to have to go back and change that. We also need to tweak the values again because the positioning isn't quite right. It's not perfect. We need to add more conditional statements into the translation of those curves, depending on whether or not there is a refrigerator, whether the refrigerator value is set to true or false. So as I mentioned earlier, we're going to go through and add conditional statements in these formulas uh, uh, quite a bit now to make sure that the behavior is exactly what we want. Again, syntax, it's not a colon, it's a semicolon. It's not a single equal sign before the question mark to test the condition. It's a double equal sign. Those are all little things that you need to know. And if you have any questions or you run into problems, make sure you check the video very closely to make sure that all of these parameters are set just right. I will be honest, if you get just one formula wrong, or if you get just one conditional statement wrong, your model behavior could be completely off. And it's easy to be off by just one parameter or by one formula. So take special care. And to simplify this model, I am going to upload it to our buildings and infrastructure community in the near future so that you have access to it. I'll put that link to the community, the page in the community where I posted this 3D XML, so that you can easily navigate to it, see the written documentation about it, download the 3D XML, and use that 3D XML in your model. You'll also see that I'm very likely going to go a little further with what we see where we get to in this video. This video is already getting a little long, so I will do a couple of adaptations offline and specifically probably put some dividers in the cabinetry, add a countertop. But the base logic, the overall behavior, and the relationships between parameters that we see being tested on the screen right now, all of that is going to be a part of that model that I upload. I've been rambling a little bit. Let's get back to modeling. I'm going to create a quick rule that sets the visibility of the refrigerator to true or false. That way it's easier to test whether or not the parameters and the formulas and the conditional statements are all working together. So now if I set the refrigerator to true, we see the refrigerator. If I set it to false, we see there is no more refrigerator. We also see that if this is set to position on the center, we are not centered when there is no refrigerator. So that has to do with the conditional statement in the translate. So we need to modify that again. We need to add a conditional statement to the translate. So if there is a refrigerator, we need the value with the refrigerator with. If not, it needs to be 0. That looks right. That translate is spot on. If we go to the right with no refrigerator, sorry, the left, we look good. If we go to the right, we look good. If we add the refrigerator, good. If we go to the left, good. And now the center, excellent. I believe at this point we are set. This is looking really good. Yep, we've tested just about everything. I'm happy with this. I'm just gonna keep combining the parameters, verifying that everything's working properly. I'm pretty certain we're good to go here. So we've created a lot of formulas. We're going to need to move those formulas from the relation set up above, down below. So select those formulas, reorder, move them down into the relation set down below. Excellent. And now let's make a UDF. Do that in the Tools tab, select User Feature, select our geometrical set. If we've done everything right, we only have a base axis system as input, and that is excellent. Let's name it the kitchen UDF. We need to expose all of those parameters to the UDF. And these parameters then, they're going to go in the dialog box of the position component command when we go to insert this UDF into our model. So select all those parameters, publish them. We need to modify the name because it gave us the full the full path through the tree. So we're going to select everyone individually, delete the path in the tree so that all that's left is the parameter name. It's easy, just a little time consuming, one by one. Kitchen length, we don't actually need that one, but we'll leave it for now. We'll take it out later. And now we need to go to the outputs. Now, I'm not a big fan of this. This isn't going to work the way I want it to because you can't dynamically control outputs of a UDF. It's not dynamic. So we're going to remove what we don't want, but we'll see when we test this. If we turn the refrigerator off, you're still going to see the refrigerator in the UDF because you can't control the dynamic outputs. So anyway, let's make a new object type. We're going to make this adaptive. We're going to call this our OT kitchen demo because this is a demo model. The resource table is easy. We're going to set the UDF, the user-defined feature, to the UDF that we just created, our kitchen UDF. Select that, click OK. And OK. I'm going to make a base AXI system publication using the define component specification command here, just in case. I don't know if this is actually a necessary step, but I'm doing it just to cover my tracks and make sure that all is good in the land of component-based design. Save my model, save my UDF, save my object type. And now when I go back to my model, I'm going to navigate to that 3D shape that contains my layouts, activate that 3D shape. I've got some working views set up in this model. So I'll activate my working view, which is going to orient me to a floor plan-like orientation, run a quick update, make sure all of my walls are up to date. And now run the position component command. I am going to search for object types. My object type, most recent object type, is going to show up first because I've got that sorted by relevance. I'm going to position this dynamically on the fly by selecting a support. It's going to create the AXI system for me on the fly, and there you go. Look at that. My kitchen space reservation is in the model. And all of the parameters that I had set in my UDF now show up in this dialog box. If I want to change the number of cabinets, you see it's going to update that 3D model. If I want to change the cabinet width, you see it's going to update that 3D model. You don't see the upper cabinets here because I've got my working view clipping the model. Let's go into perspective and navigate inside and turn off the working view, and we'll see the upper cabinets then. And hey, that looks pretty good. Should we move the refrigerator? What's it going to look like if we put the fridge on the left? Okay, that's one thing. Great. Refrigerator on the right. Let's go back to the UDF though, because I've got a couple other changes I'd like to make. I'm going to copy that refrigerator boolean and call this upper cabinets boolean, and I want that as an option now so I can create more like a kitchen island or cabinets, base cabinets without the upper cabinets. That way, if I combine all of these values, all of these configurations, I can have just the base, I can have the base in the upper without the refrigerator, I can have the base, the upper with the refrigerator, refrigerator on the right, refrigerator on the left. There's all kinds of combinations I can do with this. This is really cool. But because I've got 3 different volumes that I want to output, the UDF doesn't handle dynamic outputs, so I'm going to have to make one single volume for all of these. And this doesn't matter to me because I'm not trying to create a detailed configurator, a detailed kitchen configurator with detailed cabinets and all of that. I just want a volume that represents the overall kitchen space reservation. So if this UDF is just outputting one volume, the resulting volume, I'm all good with that. So I've got my add volumes, my booleans in my construction geometrical set, modeling all the different potential configurations of the kitchen, just the base in the top, the base top plus refrigerator, the base in the refrigerator. And it's going to be all grouped down into, and that's going to be output into one volume in the very end. And that one volume is going to be defined by the parameters if there's a upper cabinet or if there is a refrigerator. In no case do I want the upper cabinets and not the lower cabinets. So I'm not going to create that as an option in the output. I thought about it, but when was the last time you saw a kitchen with just upper cabinets? Correct me if I'm wrong. But me in this cabinet configurator, space reservation, UDF object type, we're only given the option to have base and tops, refrigerator, no just tops without the bottom. So with that rule, now listening to these parameters, you see the output geometry is dynamic and reacting to the parameter configurations that we have. I did mess up one. I gotta add an extra else if, and that is if the upper cabinets are false and the refrigerator is false, then we need to have the cabinet base and just the cabinet base. Now we can have like the island effect. And when we go back to our 3D model, you'll see I'm going to insert this as an island. No refrigerator, no tops. And this is excellent. This is super cool. You can see now through this exercise how we've created this dynamic, responsive kitchen space reservation configurator, put it in a UDF, put the UDF in an object type, and that object type now is accessible for anybody who wants to insert it into their model with the position component command. We need to make sure that we update the definition of our UDF. We need to make sure that we update the output to make sure that it's linked to our cabinet output volume. We need to make sure that we include the new parameters, upper cabinets Boolean, and we're going to remove that kitchen length Boolean or that kitchen length parameter that we don't need anymore. Save it. And now back in our 3D model, let's insert another instance. Let's insert another kitchen. We're going to put this on the opposite side of our other kitchen, and what we're going to do, let's test the positioning, left-right positioning, because we didn't get to test that on the other one. It just went straight into the right position. So position left, nice. Everything's working. Lovely, lovely. Move it into position. I do agree that the manual positioning of the position component command is not the most refined UI. You can create points and axis systems in your 3D model and use those to position your components. I am actually a pretty big fan of doing that. And now there, we've positioned our island. Let's move it a little further back. We're getting a little too close to the door, so let's move the door as well. Oh, there it is with the refrigerator. There it is with the upper cabinets. We could do that. We could leave the cabinets there, but I don't know that that's going to be ideal. Let me play architect for a minute and say this kitchen doesn't need the upper cabinets. So the positioning is fine. The door now is located in the right place. It might be a little close, but we're going to leave it there for now. It's not the point. The point isn't to make this perfect. The point is to show you how this works. So as I said, this is my object type for the position component command. I thank you so much for your attention. I'm sorry the video went a little long, but I think we learned a lot. This component will be uploaded to our wiki page so that you can download it and try it out. Don't hesitate to ask questions. Don't hesitate to give your feedback on the position component command, and have a lovely day.